Hello friends, welcome to my YouTube channel Easy Aviation. Here we discuss about the short simple topic of the aviation field. Today's topic of discussion is wingtip devices. So wingtip devices are the devices which are fitted at the tip of the wing, as you can see, which I am encircling. They are the angular extension at the end of the wing. They reduces the aerodynamic drag. How it does it, I'll explain in the subsequent lecture. Since they enhance the performance, aerodynamic performance of the aviation by fitment of this wingtip, it is also known as aerodynamic performance enhancer. How it does it? That it prevents the flow around the wingtip of high pressure to low pressure, as you can see in the picture. So there are two parts of this lecture. First is how the aircraft flies, as in like this, why the high pressure and low pressure is there, and second is how it reduces the aerodynamic drag. So let's go further. This is the pictorial representation. There are 4 pictures, and I'll be explaining first that high pressure low pressure part and then how it reduces the drag. So let's take the marker. The aircraft is flowing in the forward direction, and accordingly there is a mass of airflow which is going in the backward direction, m0. A part of this mass of the airflow is going from the top, m1, and the part of it is going from the below, which is m2. The structure of the wing is in such a manner that the velocity with which the m1 is flowing is having a velocity v1, and the velocity of m2 is v2, and v1 is always higher than v2 because of the structure of the wing. It's having a camber, and it's an aerofoil. The aerofoil is designed in such a manner, the wings are designed in such a manner that there are two mass of the flow which is flowing, and the velocity of those masses are different and not same, which implies that pressure 1, which is at the top, P1 and P2, is lower than P2. So that's the definition why there is a pressure difference at the top. Let's say P1 at the top and P2 at the bottom, and P1 is less than P2, and as I have shown in this figure, because of the high pressure at the bottom and low pressure at the top, the air is trying to leak from the side of the wing. There is a picture in this, you can see there is one wing with a conventional wingtip, there is no winglet or a wingtip device, and there is a blended winglet at one end. Since the aircraft is moving forward and the air is leaking, as you can see in this figure, air is leaking from bottom to, aircraft is going in direction, air is leaking from bottom to the top, and since the wing is moving forward, it leads to the formation of vortex, as you can see in this figure. If you use a wingtip devices, this leakage of the air from bottom to top will reduce and leads to the formation of less vortex. Now coming to the part of how this is reduced, how the drag is reduced. So if you have a basic understanding of a cambered airfoil, so this is an airfoil. Let's say this is a wing, and this is a chord, and this is the relative airflow, the airflow which is hitting the wing. We all know that the lift generate is in the perpendicular direction of the relative airflow, and this is the drag in the parallel direction, or in the direction of the airflow, and this is the resultant. So when the air is leaking from bottom to the top, and the air is coming from here, it try to change the direction of the wind of the air from this to this, because of there is a top force which is acting on the air, on the direction of the air. One main part which I forgot, that this shaded area is the effective angle of attack, which defines the lift generation. If you go further, so because of this vortex generation and because of this leaking of air from the bottom to the top, the direction of the relative airflow will go to this direction, and the effective angle of attack 2 will be less than angle of attack 1, which further reduce the lift generation and increase the drag generation, and the resultant will further reduce. So this is how this is the explanation of how the non-fitment of wingtip devices leads to the higher leakage of air from the bottom to the top, and which further leads to the vortex generation and reduction in the angle of attack. This is also known as induced drag, because why induced drag? Because it is induced when the aircraft is flying in the forward direction and there is a leakage of the air. The induced drag will always be there, but with the wingtip devices, the induced drag will reduce a lot as compared to the non-wingtip or the conventional wingtip. So I have explained both the part. So what are the advantages? Coming to the next part, what are the advantages? It increases the fuel efficiency, because if you reduce the drag and increase the lift, it will increase the fuel efficiency. Second is the lift production. I have already discussed in the previous part. It reduces the shock drag. Is a further part, but this is one of the advantages. You can just note it down. It reduce the shock drag, and the takeoff and climb performance when the velocity is very less during the takeoff and the landing. At that time, this wingtip devices, because there is a higher lift production factor, it is one of the advantages of having a wingtip devices. What are the disadvantages? One main disadvantage is that the profile drag. Profile drag is the drag because of the structure. So since you are adding another structure here, it will increase the profile drag, but this increase in the profile drag will be very less, or you can say compensated by the increase in the lift production and reduction in the vortex generation. Coming to the last part, the types of the wingtip devices. I will not be going further deep, like which type is will be utilized or is specific to what kind of aircraft, but this is the data which I have found in the Wikipedia and the open sources. So there is a split tip winglet, the wingtip fence, sharklet because it look like a shark. There is a blended winglet. There is a special. It's for the spheroid winglet is also there in the Falcon 15. I mean, it's more of an experimentation part. This is the 737 Max. This is a split type winglet. Split type as in like this, which is there in the 737 Max Boeing. And this is a Tamarack Aerospace active winglet device. I mean, this is the future, as you can say. This is further in the studies where the active winglet, when you have a very high speed during the cruise time, these winglets can be the angle can be reduced. I mean, they can act like a normal wing. So these kind of active winglets are also there. Canted winglet, Airbus A320 sharklet, Boeing raked winglet, as you can see the end, and this is A310-300 Airbus wingtip fence. So you can say that's a raked winglet also. So here I conclude my topic on the winglet. I hope two basic concepts of high pressure, low pressure, why the aircraft, how the aircraft fly, the lift generation, and then further how it reduced the availability of having a wingtip, how it reduced the induced drag. So all these important part of having a winglet or wingtip devices, I hope I have made them clear. So if you have any further query, if you want me to cover any specific topic, you can please post it in comment section. Here I sign off. Thank you.